Right, it looks like we have a full house, so let's kick off. Hello and welcome to this AI Edge Labs and Sunlight webinar. AI Edge Labs and Sunlight recently announced a partnership to offer comprehensive and secure edge computing solutions. I am Hannah Meadow, your host today and Marketing Director at Sunlight. On the webinar with me, I have AI Edge Labs CTO Oleg Magrin and Sunlight founder and CTO Julian Chesterfield. They will be discussing how to secure distributed IoT applications at the edge. But before we start, we have some housekeeping as always. You can submit questions at any time via the Q&A function. We will address as many as we can at the end of the session. If we are not able to answer all of your questions in the allocated time, we will follow up with you individually. Before I hand over to the speaker to kick off the session, let's get everyone involved with a quick anonymous poll. You should see a question pop up on your screens now. Right, I'll give you a couple of seconds to just answer that. So the question was, have you or someone in your organization experienced an edge security attack? And the positive answer is most of you have said no. So, and hopefully it stays that way, but we all know we have to be careful. So that's why I'm going to hand over to our first speaker, Julian Chesterfield.
Thank you, Hannah, and welcome everyone to the webinar. Thank you for joining today. Yeah, we're very excited to be working closely with the folks at AI Edge Labs. And so I'm going to talk to you a little bit about, from the Sunlight perspective, some of the components that are important to consider regarding security for the edge in particular. And I'll cover a few topics today. First of all, some of the risks that we perceive that's the highest threat really for organizations who are operating at the edge. Talk a little bit about the edge because I think it's not always apparent to everybody exactly what is the edge and what does that mean. And then talk about Sunlight and really how we solve some of the challenges of deploying and managing infrastructure at these edge locations. And then we'll talk about the combined solution with Sunlight and AI Edge Labs and how we're jointly combating these security threats and risks in these distributed edge environments. And then follow that with a demo showing a little bit of the Sunlight side, and I'll hand over to Oleg to present how that's then sort of managed and supported by the AI Edge Labs component itself. Okay, so straight in. I think some of the highest threats for organizations operating at the edge really are cybersecurity risks, and a lot of these we're very familiar with some of the techniques and solutions that people deploy in centralized data center environments. I think one of the big challenges with the edge is that when you have lots of distributed edge locations, which may be themselves quite exposed and accessible, that adds a whole different level of complexity, and it gives you a much wider attack surface in particular. So there are similar techniques for defending against these sorts of risks and challenges at the edge, but of course they have to be augmented by this capability to manage these threats across a distributed footprint in particular. So in particular, things like distributed intrusion detection, being able to look across the whole picture of edge locations, to be able to make decisions about coordinated attacks or distributed attacks that one site might be experiencing, that you can inform other sites in order to be able to lock down and protect against those sorts of threats. Of course, there's things like firewall functions that are required to make sure that applications that are executing in those environments, which aren't always up to date, they might have security vulnerabilities, they might have exposed ports, for example, being able to lock those down and make sure that they're not being accessed unexpectedly. And then being able to really create a sort of security perimeter across all of these distributed services that are executing at the edge. And the other thing to highlight, and this is also true in the core data center, but absolutely true at the edge as well, is that as we increasingly move towards multi-tenant environments with many different kinds of applications and potentially different tenants who actually own those applications executing at the edge, it's important to know that there's proper security and isolation in the stack itself to make sure that one misbehaving application can't cause problems for other apps that are trying to run in that same environment. So really, these are the challenges that Sunlight and AI Edge Labs are looking to solve, and we've created an integrated solution in order to combat these risks. So a little bit about the edge. For us, the edge is really anything that operates outside of the core data center. So one very common use case is in industrial environments where a lot of factory environments are becoming much more automated, leveraging IoT sensor devices and video devices and temperature sensors and things like that to be able to create more automation in these environments, to have more autonomous operations, to be able to make decisions quickly at the factory floor itself. Other examples in the sort of retail space, similar set of challenges actually. What we're seeing is this move towards retail stores and environments wanting to have a more immersive technology experience. So being able to combine some of the sort of automation and ease of use of online shopping and retail, being able to bring those experiences into the store. Things like Just Walk Out technology is a great example of that. And then also in the energy sector, there's a huge amount of innovation going on in this space, whether that's in traditional oil and gas or whether that's in newer renewable type energy generation and so on. There's a lot of important work that can be done around automation and more efficient analysis of the environment in order to do better energy generation more efficiently. But in all of these environments, what we see is that the big challenges that are starting to emerge at the edge are that having these single purpose solutions running on discrete hardware becomes very costly because you end up with a lot of infrastructure sprawl. You don't have a lot of space in many of these environments. And there's a lot of data that's starting to be generated, particularly if it's video related data, for example. There has to be a lot of processing done locally and it has to be done fast. Complexity is another issue. Many of these environments are not traditional IT environments, so you don't have a lot of IT personnel with a lot of skills on site to be able to manage infrastructure. And then lastly, there's this requirement to, new solutions are coming out all the time, and rolling out new infrastructure in order to support a new application or solution becomes very costly and very time consuming in order to do that. So Sunlight really solves these challenges by bringing micro cloud capability, what we call edge appropriate infrastructure, being able to deploy hardware and software and the entire management stack onto a very small footprint that runs at these distributed edge locations. And all these edge locations are tied together via a centralized dashboard that allows you to manage and control both the infrastructure, so being able to monitor the hardware nodes and all of the execution environment at the edge, but most importantly and very critically, the actual applications that are going to deploy in that environment as well. And because of the way that we're architected and built, we can support an entire spectrum of applications, all the way from legacy environments that might run on things like legacy Windows Server applications, all the way through to containerized and more modern application architectures as well. Sorry, just skip the slide there. Under the hood there, we have what we call a hyperconverged edge stack. So this is designed to be very highly available, fault tolerant at the edge, and very autonomous and resilient. And then, of course, that's centrally managed via the Next Center component that manages all of the application and edge orchestration, and of course, disaster recovery and backup capabilities as well. The app lifecycle piece is very critical, particularly as the edge scales. So having a distributed edge environment with lots and lots of remote sites, being able to automate the entire application lifecycle process is very important. Everything from deploying apps, monitoring them, managing them, updating, security patching, and maintaining them as well. So how are Sunlight and AI Edge Labs combating some of this edge risk? So first of all, Sunlight focuses on building a highly secure managed infrastructure for the edge. So we focus on the infrastructure layer. We make it very highly available, so you can drop in 2 or more nodes into an edge location and it gives you full high availability. If you have a failure or if somebody pulls a power plug or some problem occurs in that environment. We run that on very robust and ruggedized and secure edge devices. So that ensures that that edge infrastructure footprint is extremely reliable and always available. At the Sunlight level, we can scale up to thousands of these edge sites, and we can manage those all from a single centralized dashboard. At the application execution level, we have fine-grained application execution isolation. So that's really key, particularly environments where you may have untrusted applications running alongside some of your key or critical apps that you need to deploy. And then also, of course, as part of that infrastructure management, is being able to have user access control. So many organizations have different levels of users who need different types of access to the infrastructure. And Sunlight really provides that fine-grained user access capability. Then on top of that, AI Edge Labs is providing all of the AI-powered security for those applications that are going to execute from the Sunlight application library and be pushed out to those edges on top of that Sunlight distributed edge infrastructure. And that's providing things like instantaneous insights and continuous monitoring into security properties and threat detection and so on. Being able to do real-time threat detection is really key. Leveraging that distributed insight and using AI algorithms in order to respond and combat these security attacks that may start in one location and may scale out across many locations. And then, of course, also being able to provide enhanced compliance for those environments. So this integration of Sunlight and AI Edge Labs provides a highly scalable and what we call a secure edge perimeter. So this is for any application that you need to to deploy and execute at a remote site across many distributed locations at scale. So let's see it in action, and we'll now run through a video showing some of the deployment capability and how the integration with AI Edge Labs via the Sunlight Management Control allows you to deploy and manage your Sunlight Edge infrastructure with this AI Edge Labs enhanced security perimeter. So the first thing that they do is they log into their central dashboard, and that will allow them to see all of their infrastructure. If we go here to the infrastructure section on the dashboard and click on clusters, we can see all of the clusters that have been associated with this dashboard. This cluster that was received by the customer has now been powered on and it shows as enabled. So it was shipped out, it was already pre-installed, and all they've had to do is apply the power. And we can see that this is 2 relatively small nodes. We've got 8 cores on each node, and we've got 16 gigabytes of memory. The core usage here shows as reserved because we've already created a resource group on that cluster, which means that we're ready to start provisioning applications onto that cluster. You can see that the memory, however, because there's no applications actually deployed, is completely unallocated. And in fact, this also shows just how little memory the Sunlight platform consumes of the physical node. Out of 16 gigabytes of memory, we can see that there's the majority of that physical resource available. So the first thing we'll do is set this up in a fault tolerant mode. So I'm going to connect to the remote dashboard here. So that link loads the dashboard of the remote cluster. We can go into the cluster. We can obviously see all of the physical resources of that cluster. But one of the things that we're going to do here is find the secondary node. That's the primary. That's the secondary. And we're going to designate this. We're going to enable fault tolerance for this cluster. So that action is now completed. And we can see that that secondary node is now designated as the failover primary. So this cluster is completely fault tolerant enabled, which means that any applications that we deploy on here will fail over and continue to run in the event that one of these two nodes fails. Let's go back to our main dashboard. We reload this now. We now see the primary node and the failover primary. So the first thing we're going to do here is go into the marketplace. So now we're going to demonstrate how the Edge Labs integration works. It provides a framework for monitoring intrusion detection and other attacks on applications that are running out at the edge. So we've integrated our application library framework with the Edge Labs security tools, which means that you can now enhance any application in the library to leverage the Edge Labs security features. And you can see that if you go into the details of the individual Ansible recipe and you look at here in the roles, you'll see that there's an Edge Labs role that allows us to define exactly the parameters that it's going to use to connect to the centralized Edge Labs dashboard. So we're going to go ahead and execute this recipe. You can see here we have a central dashboard from the Edge Labs team. And I'm going to log in here to my dashboard. And we can see there's already a few instances that are being monitored. And we're going to launch a new instance and see it show up in the list. So we're just deploying a basic Ubuntu host, but this could obviously be a much more complex application running on top of this platform. So we're going to select our demo cluster, and we can see that in the list here, it shows us all of the clusters that have the resources in order to host and run this particular application that we're deploying. And we can see here that this resource on the SKO demo is capable of running the recipe. So we're going to apply the recipe, and that will now start deploying. It's in status build, and shortly we will see the application show up as completed. So we can see the status has now changed to installing applications. So let's look now at the status of the recipe. We can see that it's now gone to active, which means that the application is deployed and all of the configuration logic has been applied against that environment. So the VM now is running, and because it was enabled with the parameters to connect it to the Edge Labs AI security framework, we can now go to our central Edge Labs dashboard, and we can see here that there is now a new instance which is shown up here. The Edge Labs security perimeter is now activated automatically for this new workload and for any subsequent workloads that we are going to deploy from the Sunlight application library. So all these new workloads are automatically associated and secured by the Edge Labs central dashboard. So I'm going to hand over now to Oleg to explain the types of security threat and the management techniques that are provided by the Edge Labs platform.
Thank you, Julian, for introduction. So today we'll talk about Edge security risks. We see how our clients and partners adopting Edge. We see how they transform IT infrastructure. So in this session, I will review the difficulties of securing data on the Edge. We will also explore some of the latest developments and discuss best practices. Let's get started. So there are many definitions of Edge security. Our clients usually mention, first of all, it's protection of sensitive data at the Edge. This data may include personal, financial data, company information, client information, and so on. So company needs to make sure that all the measures are in place. Second concern, it's untrusted devices that connected to the Edge. They could be connected to the network without proper security, credentials. These devices could be compromised by malware. In some cases, security breach or cyber attack on device usually leads to network downtime and disruptions in the service. The lack of physical control on the device means that Edge device may be vulnerable to a physical attack, such as client data sniffing or service disruption or data destruction and something like this. Like you see in the picture, there's the Edge cell tower that deployed in the middle of desert. So maintaining and securing data in such cases especially hard. Ensuring customer trust. In today's digital age, customers expect their data to be more protected, which impacts to customer trust. And of course, compliance and regulations. Many industries are subject to regulatory requirements for data protection and privacy, and the failure to comply this regulation can result in significant fines and legal penalties. Last year, AT&T released an interesting report. They asked about security concerns in their clients. You can see the division by industries where ransomware and attacks against data at the network edge are the most concerning. Also, data sniffing and spoofing show significant concerns too. These numbers were based on the network industry. However, many other reports say that the number of threats is steadily growing, especially on the edge that connected to IoT. This is the example of potential risk for energy grid deployment. These threats could bring significant damage to the customer network. An attacker can develop attack against the edge and even core network that sits on the cloud side. For example, LoRaWAN IoT protocol vulnerable for replay attacks, when attacker can intercept and replay LoRaWAN network messages and use them to gain unauthorized access to the network or launch other attacks. In case data interception, attacker can use specialized equipment to intercept and read LoRaWAN network traffic. One of those examples of this equipment you can see on the screen. Spoofing, when attacker can spoof or impersonate LoRaWAN devices or gateways, and potentially could get access to all connected devices inside the network. The Mirai botnet had a serious effect if we're talking about financial losses. Here are some key facts about probably the most famous and dangerous botnet. By this time, more than 600,000 IoT devices are infected. The botnet is responsible for launching biggest DDoS attacks, more than 1 terabit per second world. In 2016, one of the largest German internet provider, Deutsche Telekom, suffered a massive outage where almost 1 million of customers were knocked out offline after routers compromised. In 2023, Cloudflare reported about biggest DDoS attack from Mirai botnet with 1.3 terabits per second. Like you see, this botnet is very dangerous for IoT ecosystems, even in modern days. Let's talk about our platform. Our clients having traditional security tools see difficulties in deploying security on remote sites, especially if they are not constantly reachable or manageable. So we see a big value in AI because it could provide a lot of help for protecting remote workloads. It could provide immediate reaction to attack, automations, and low error rates. We call it low false positive rates. So actually sensors ready for offline and autonomous work, they have a very low footprint to the system. Cloud side of the product provides deep visualization of the attack surface. It's actually part of Security Operations Center. Deployments based on the containers and upgrades are automated and coordinated by the Cyber AI team. So our platform provides protection against network attacks and malware. For example, we provide protection against DDoS attacks, brute force, ransomware, IoT compromise, flooding, man-in-the-middle attacks, and many more others. So these are the list of capabilities that the platform provides: autonomous network threat detection and prevention, endpoint protection on the edge, network visibility, smart firewalling. From cloud side, there's the SOC dashboard with multi-tenant support, and we have an integration with third parties in order to report about events into other systems like Splunk, Grafana, and others. Deployments are distributed. It can be activated with Kubernetes. It can be activated through the integration partners like Sunlight. So let's say you can't fully control remote security posture, but you can include smart algorithms on the remote side that will do significant part of the work instead of you. These are the key points that gives us machine learning. First of all, network verification happens on IP flow pairs, source IP, destination IP. For each connectivity and its ports variation, the low false positive rate is very important because the number of IP flow pairs can be huge, and it's very critical to have it ultra low. For us, it's more than 99%. By having intelligence on remote side, you don't include cloud side decision for threat detections, which significantly improves detection speed. We use reinforcement learning for constant improving security posture. Also, local machine learning saves cost for bandwidth and preserving data locality for compliance-sensitive deployments. AI sensors usually can be deployed to the edge in the form of container. It's actually a lightweight micro pipeline with models on board, and it continuously provides traffic and process verification on the host. We use Rust language for computation performance of the network data and feature preparation. eBPF hooks and OS telemetry metrics are ingested into the set of ONNX models for the inference and decision-making. So, product itself focusing on the Linux-based operating systems, which are de facto standard for the edge IoT. And if it's talking about distributed deployment, installation with Kubernetes or edge orchestration platform is quick and easy. So let's jump to the demonstration of attack scenarios and how Edge Labs detect them. We will demonstrate two kinds of attack: brute force and RP spoofing. Next demo is pre-recorded. Please note that the next examples are focused on detection for demonstration purposes. Automated prevention, if it's enabled, is possible too. So let's start.
MQTT is a widely used protocol for communication between IoT devices and servers. One of the potential security threats associated with MQTT is credential brute forcing. If the attacker is successful in brute forcing the credentials, they can gain access to the device and potentially carry out malicious actions. For example, they may be able to read or modify data sent from the device, or even take control of the device itself. For demonstration purposes, we've activated one sensor per host in network and see that there are no incidents on the historical map for the past day. This is the scheme of our test environment that we're going to protect, which is the small network with MQTT server and clients connected to it. In this particular deployment, traffic from the network mirrored to the edge host with sensor. For the attack, we will use MQTT-TSA tool that uses dictionaries and targets to our MQTT server with the known port and user. So, let's start dictionary brute force attack against MQTT broker. Platform immediately reports about the attack and escalating incident, with source of the attack and details about incident and recommended remediation. Additional view is available for more granular security events and shows particular events of the attack and can be used in further analysis. Edge details view shows the brute force incidents and alerts groups associated with them. In the next example, we will demonstrate ARP spoofing. This is the type of attack where an attacker sends falsified address resolution protocol messages over a local area network. By doing so, the attacker can associate their own MAC address with the IP address of another device on the network, effectively redirecting traffic intended for that device to the attacker's own device. This can allow the attacker to intercept, modify, or steal sensitive data being transmitted over the network. ARP spoofing can be prevented through the use of secure network protocols and encryption, as well as by implementing measures to detect and block suspicious network activity. Test environment for emulation of the attack is the same. The goal of the attacker is to gain access to all communication between mirror victim 1 and MQTT server inside the network. Attacker sits inside the perimeter and displayed on the scheme with the name attack logger. So, let's prepare services with the MQTT clients that will periodically publish some telemetry to the MQTT broker from victim node. For execution ARP spoofing attacks, we will use ARP spoof open source tool that will modify ARP response between victim 1 and MQTT broker. In this command, we're telling these two hosts to send packets through the attacker machine. Generally speaking, this tool is overriding MAC addresses in routing tables. Let's check if this attack was successful. To do that on attacker machine, we will run TCP dump command and verify local traffic. In TCP dump output, we see IP flow pairs that represents communication between victim 1 and MQTT broker server, which means that the attack was successful. An attacker right now acts as a man in the middle and has access to all communication. Like you see on the screen, Edge Labs immediately detects and prevents this attack. So in dashboard incident instantly escalating in details about incident provided for better investigation the case. This information would include attacker details, origin of attack and mitigation steps.
So, thank you all for the opportunity to speak there. And I think we still have some time for questions.
Thank you, Julian and Oleg. That was really useful. Thanks for sharing that. We have received a lot of questions. We started a little bit late, so let's keep going at least till 1:15. So before we start the Q&A, we do have one more quick anonymous poll. So this will show up on your screens now. Right, I'll just give you a few seconds to answer the question. Have you considered investing in security products before now? So I'm going to launch the results. Hopefully you can all see that. It looks like the vast majority of you have already invested. And if not, you've at least looked at it. So that is really useful to see. So let's start with the Q&A. Okay, if you haven't seen already, you can submit via the Q&A function on Zoom. The first question that we have is probably for you, Julian. If the edge is so hard to secure, would it be better, would we be better off running our apps in the cloud?
Yeah, good question. I mean, I think, you know, as I said in my introduction section, I mean, I think, you know, the edge does bring a new dimension of complexity because of the distributed nature. However, I think the reality for edge applications is that, you know, these applications have to run at the edge. I think most of them, in most cases, it isn't really a question of whether you can push all of that processing and logic into the cloud. I think a lot of these apps do have to be able to run close to sources of data. And so, you know, it's really up to us as system architects and technology innovators to really solve the challenges around you know, how we you know, secure that perimeter and how we make applications execute safely in those environments.
Thanks, Julian. Next question for you, Oleg. Does Edge Labs need to be installed as a role on every application container on an edge device?
Actually, probably a question for me.
Yeah.
Sorry about that.
That's more to do with the Sunlight logic. So in order to activate the Edge Lab connectivity parameters, you do have to have a role included. There are ways to do that on a global deployment mechanism, though. So if you have a set of applications that are already designed and tailored to be able to execute in your particular edge environment, then you know, we can apply a global rule to update all of those apps to be able to pick up those properties, and then every app that you deploy then automatically gets connected into the AI Edge Labs central manager.
Great. Right, one for you, Oleg. What are the security vulnerabilities of the Edge platform itself?
Yeah, so actually vulnerabilities is mostly about software that sits on the edge. It's all about what you installed. So you will get some CVEs, vulnerabilities, and this actually opens opportunity for the attack. So usually you should use some EDR solution, endpoint detection and response, or probably work on some patching or fixing these vulnerabilities. For example, you install some MySQL server on the remote side and it has a very critical vulnerability. The one way to fix that is to find a newer patched version of MySQL and upgrade it. If we're talking about in general, what's the problems and it's mostly about the configuration. You on remote side, you can't control this edge. You can't control this security posture properly. So if you're talking about IoT connectivity, there are a lot of problems comes with this weak default passwords, with not perfect software that sits on this IoT connectivity. But I would say the lack of control, lack of opportunity to configure properly on remote side is the biggest challenge on the edge deployments.
Yeah, and I would, if I may jump in, I mean, I think there are also vulnerabilities below the applications as well. So in the infrastructure itself, you know, at the system level, I mean, this is certainly true for the AI Edge Labs components and also for the Sunlight components. You know, we have to make sure that our API interface is always secured and you know, not vulnerable to these sorts of attacks. At the Sunlight level, we actually proactively ensure that there are no exposed ports. So we don't have any, a lot of solution components. If you look at like a Docker container stack, for example, there'll be a number of different services and ports that are running, that are providing different services and so on. With our platform, we always make sure that we don't expose those, so they're not presented at all to an external or a public-facing IP address, whether that's a locally assigned IP or a public routable IP or whatever it may be.
Right. We still have more questions, so hopefully you can hang on a little bit longer. So, like you mentioned, performance and a low footprint system. What's your minimal requirement to install sensor?
That's a good question. So our minimal recommended requirement per host, like per edge device, it's like 1 GB of RAM and at least, of course, 1 CPU, right? And we actually tested on 512 megabytes configuration. It was like very legacy and basic machine. In the runtime, our sensor usually consumes in the range from 20 to 100, 150 megabytes of RAM. It depends from the different conditions, traffic, and so on. So that's like in general, like, but we recommend to have it at least 1 gig per host.
Useful, thank you. So I think one last question for you both. What are the competitive advantages of Sunlight and AI Edge Lab solution?
So I can jump in first, Oleg. I mean, I think providing security, particularly for large-scale distributed edge environments, has to be a multifaceted approach. It's a holistic security solution across the entire stack. So everything from the infrastructure layer, actually the direct connectivity to the physical network interfaces, all the way up the stack, the components, the applications, the framework that's running on top of that. I think our biggest competitive advantage here is that we have a fully integrated solution that allows any type of application to run, to be able to build the security perimeter around those apps that need to execute in those environments.
I can add from my side about AI Edge Labs. So we think that our main competitive advantage is that we sit on the remote side, on the edge. That includes machine learning and gives a lot of automation in terms of what you can't control on remote side. Our competitors mostly use some telemetry-based approach when they transfer the data to the cloud, and after that process and provide some detection on the cloud side. And also we focusing on more like modern ways of deployment with such companies like Sunlight and Kubernetes-based installations. And we see like big players on the markets like Fortinet and others. They use like heavyweight approaches with virtual machines, or even ask for installing hardware equipment for firewalls and something like this. And that's like biggest differentiators what we can define between these companies. I hope that I answered this.
No, that was great. Thank you. That was really useful. So I think that's really all we have time for today. I'd like to thank everyone for joining us and for staying through the whole presentation and Q&A as well, and submitting your questions. So I hope you found it interesting. We will be in touch with a short feedback survey. So I really ask, please take a minute to answer honestly. It will help us to improve for future events, and also provide some ideas for topics you'd like to hear about in future. So thank you, Julian. Thank you, Oleg. It's been an absolute pleasure having you both here today.
Great, and thanks everyone for joining.
Thanks, everyone.
Bye-bye.